Reorganization means only during the chemical reaction, only rearrangement of the atom will take in place. We have to consider the relative abundance along with the atomic masses. Then we can easily identify the atomic mass of the carbon. We cannot use that word as a molecular mass because the constant particles are ion here. That is why we are using the another new word known as formula mass. Dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in our last discussion, we were dealing with the unit called Some Basic Concepts of Chemistry. Under that, we have studied about the different laws. They are known as law of chemical combination. So we have seen with the 5 different law which is stated by the different scientists. The first law is a law of conservation of mass, and second law is a law of definite proportion, and third law is a law of multiple proportion, and fourth law is a Guy-Lussac law of gaseous volume, and the fifth law is a Avogadro law. In all this law, we have found out that the two different elements are combined and they give rise to the product. Hence, it is named under the law of chemical combination. Today, we will move on to the next topic of this chapter is atomic theory. And also, we will discuss what is atomic mass, what is gram atomic mass, and how to know the average atomic mass, and what is molecular mass, gram molecular mass, and the formula masses. Okay, we'll see what is the atomic theory first. So atomic theory was the first theory was stated, or it is founded by the scientist called John Dalton in the year 1808. So in the year 1808, John Dalton was the first scientist. He put forward this theory. And also, he is the first scientist. He gave the basis for the some of the information about the atom. And also, he wrote a book called as A New System of Chemical Philosophy. A New System of Chemical Philosophy. In this book, he wrote some of the postulates regarding to the atom. Let's see which are the postulates. The first postulate states that matter consists of indivisible atoms. Matter consists of indivisible atom, which means to say that every matter which consists of atom, and we cannot divide the atom further. But actually it is wrong. We all know that atom can also further divided into 3 different subatomic particles. Which are those? Proton, neutron, and the electron. But at the time, in the 18th century, he was a scientist. He used to say that the atom we cannot further divide. Okay. And later, he told that all the atoms of the given element, if the atoms of the same element, they have a identical mass and an identical property. If you consider the 2 different elements made up of 2 different atoms, they possess a differs in the masses as well as the differs in the property. So this was the second postulate was given by the John Dalton. If you consider the same element, they have a same property and same masses. If you consider the different elements, they have a different masses and a different property also. Coming into the third postulate, he says that the compounds are formed by the atoms of the different elements are combined in a fixed ratio. The best example is water. If you consider the water, we know that water consists of 2 different elements, right? The hydrogen and the oxygen. So this hydrogen and oxygen, they present in a fixed ratio. Only two hydrogen can combine with one hydrogen forming water. So this was the idea was already given by the John Dalton in the 18th century. Coming into the fourth postulate, he says that the chemical reaction involves the reorganizations of the atom. Reorganization means only during the chemical reaction, only a rearrangement of the atom will take place. In that chemical reaction, remember, he says that atom neither be created and nor be destroyed. Which means to say that during any chemical reaction, we cannot create the atom or we cannot destroy the atom. So this was a fourth important postulate was stated by the John Dalton in the year 1808. Remember, this was a basis for the atomic theory and also for the other scientists to discover more about the atom. Hope you understood with this. Fourth postulate was given by the John Dalton. Now, let us move on to the next topic of this unit is atomic mass. So, what is this atomic mass? Just now we have seen with the atomic theory, then what is this atomic mass? Simply we can say that atomic mass is nothing but a mass of the atom. It is nothing but a mass of the atom. We all know that every matter is made up of the atom. Then how to find the mass of the atom? We all know that each atoms are extremely small, right? The atoms are extremely small, right? Then how to find out the mass of the atom? It's so difficult, no? Because they are present in a very large number and even though they are very small. How to calculate this mass of an atom? Now, today we have a sophisticated technique called as spectrometry. By using this technique, we can find out the atomic masses. But in the 19th century, scientists, they started calculating the atomic masses by considering the standard element. What is the standard element? So, we all know that in our periodic table, there are 118 elements will be there. So, they have picked the one element from the periodic table known as hydrogen. Okay. So, they have taken the hydrogen as one of the standard element whose atomic mass will be known. Okay. And they started comparing with the other element. So, in order to calculate the unknown mass of the atomic mass of the unknown element, they use this standard. But later, they have faced a many difficulty by using this hydrogen as one of the standard to find about the atomic masses. Later, scientific community, they started using the another element known as carbon 12. We are all familiar with the carbon, right? So this is one of the element which is found in the nature abundantly and they exhibit in a 3 different isotopic form. Do you all know that? Which are those? Carbon 12, carbon 13 and carbon 14. Carbon 12, carbon 13 and carbon 14. Among them, the carbon 12 is one of the element which is abundantly found in the nature. And they have used this carbon 12 as one of the standard and they know the atomic masses of this carbon 12 and they used to find the atomic masses of the other element by considering this carbon 12 as a standard. Okay. So then how to describe this atomic masses? They have given a definition called as atomic mass can be defined as it is nothing but a ratio of the mass of an atom of an element divided by 1/12 mass of 1 atoms of carbon 12. Imagine you have a carbon. Okay, so they have divided one single atom of the carbon into 12 portions. Okay, so only one portion imagine they have taken out. Okay, Imagine this is the 12th portion. So, whose mass will be known? So, by taking this standard, they used to find out the atomic masses of the other element, and they have stated that it is nothing but a ratio of mass of an atom of an element divided by 1 by 12 mass of one atom of the carbon 12. 1 by 12 of 1 atoms of the carbon 12. Okay. Then, what is the mass of 1 atoms of the carbon 12? That is known as atomic mass unit. Okay. So, it can be defined as 1 atomic mass unit can be defined as mass which is exactly equal to the 12th of the mass of 1 carbon 12 atoms, carbon 12 atom. To know this 1/12 mass of the 1 atoms of the carbon, so they have used that atomic mass unit. So atomic mass unit is a mass of the 1 by 12 of 1 atoms of the carbon. So it can be denoted as 1 AMU, that is atomic mass unit. So did you all understood? So this is a mass of the 1 by 12 of the 1 atoms of the carbon 12, which is equal to 1.66056 into 10 power of minus 24 gram. So this was a value of 1 by 12 of mass of 1 atoms of the carbon 12. I have denoted here. This is a value of 1.66058 into 10 power of minus 24. This is the value for the 1/12 portions of mass of 1 atoms of the carbon. So by using the standard, they usually calculate the atomic masses of the other element. Let's see how do they calculate. Okay. The mass of an atom of hydrogen is 1.6736 into 10 power of minus 24 gram. So this is a mass of the hydrogen. By using this, we can calculate the atomic mass of the hydrogen. How we can calculate? By using this formula, that is mass of an atom of an element divided by 1/12 of mass of 1 atoms of carbon 12. Now we know the values of this. This is 1.66 into 10 power of minus 24. We know this value and we know this value. So by comparing with this standard with this, and we can get the atomic mass. So here I have taken the example of the hydrogen. The atomic mass of the hydrogen is 1.6736 into 10 power of minus 24 divided by, this is a value of 1 AMU, that is atomic mass unit. Okay. So if you divide this value, you will get the atomic mass of the hydrogen. You will get the atomic mass of the hydrogen. Like this, scientists in the 19th century only, by using the standard of a carbon 12 isotope, they calculate the atomic masses. It's very simple. Remember, to calculate this atomic mass, they use the one single formula. It states that the mass of an atom of an element divided by 1 by 12 of mass of 1 atoms of the carbon 12. So what is the value of this 1 by 12 mass of 1 atoms of carbon 12? It is nothing but a 1 AMU, which is equal to 1.66056 into 10 power of minus 24 gram. This was a standard which is taken by the scientists to calculate the atomic mass of the other element. Here you can see that I have taken the example of the hydrogen whose mass is 1.6736 into 10 power of minus 24. I am dividing the mass of an hydrogen with the 1 by 12 mass of 1 atoms of the carbon 12. Okay. If you divide this, you will get the value of this. This shows that this is the atomic mass of the hydrogen. Later, we remove this AMU. Instead of this, we are using a new terminology called as unified mass. Unified mass is nowadays will be used instead of EMU. This was an idea was introduced by the scientific community in the 19th century. Okay, hope you all understood with the atomic masses. Next topic is gram atomic mass. So it's very simple to express the atomic mass in terms of the gram. How to express this? It is nothing but the atomic mass of an element expressed in the gram. Then it is said to be gram atomic mass. If you express the atomic mass in terms of gram, then it is said to be gram atomic masses. Here I have list the example of the oxygen. This is the atomic mass of the oxygen is 60 AMU. If you write it in terms of gram, then it will become gram atomic mass. Gram atomic mass. Just simply we are expressing the atomic mass in terms of grams. Okay. Then it will become gram atomic mass. Then we'll move on to the next topic, that is average atomic mass. What is this gram average atomic mass? How to calculate this average atomic mass? Let us discuss. We all know that so many elements are there in our nature and they are known as naturally occurring elements. The best example is carbon. So it is one of the element which is found in a 3 different isotopic form, right? So they are carbon 12, carbon 13 and carbon 14. So this is a single element which is found in a 3 different isotopic form. Then in such cases, how to calculate the atomic mass? By taking the average of the abundance and also by taking the atomic masses. So for each elements, for each isotope, we have to consider the relative abundance along with the atomic masses. Then we can easily identify the atomic mass of the carbon. Atomic mass of the carbon. So why we are using this average atomic mass? To calculate the atomic mass of the single element. Okay. Because some of the element they found in a different isotopic form. In order to know the atomic mass, we are expressing in terms of the average atomic mass by considering the relative abundance and also with the atomic mass. Here I have taken the example of the carbon which is exhibit in a 3 different isotopic form, that is carbon 12, carbon 13 and carbon 14. Okay, and their relative abundance is 98.892 and 1.08 and 2 into 10 power of minus 10 and the atomic masses I have listed out. Now, in order to calculate the atomic mass of the carbon, I'll consider the relative abundance of the carbon 12 into atomic masses plus relative abundance of the C13 and this is C12. Okay, C13 into atomic mass of the C13 plus the carbon 14, the relative abundance into the atomic masses. If you simplify this, you will get the atomic mass of the carbon. You will get the atomic mass of the carbon. This is how by taking the average atomic masses, we can calculate the atomic mass of an element. Understood? Next, we'll move on to the molecular mass. Now we have understood what is the atomic mass and how to express the atomic mass in terms of gram, and also we have understood that how to calculate the average atomic mass if the elements they are found in a different isotopic form. Now we'll move on to the molecular mass. Molecular mass, it is nothing but a sum of atomic masses of the element present in the molecule. Here I have taken the example of carbon dioxide. We know that carbon dioxide is a molecule which is formed by the 2 different elements. The first one is a carbon and second one is a oxygen. So if you consider the atomic masses of these 2 elements, then it will become a molecular mass of that molecule. So how to find out this? By It is obtained by multiplying the atomic masses of the each element by the number of its atom and adding them together. By adding them together, you will get a molecular mass. Here we know that the carbon and oxygen are the two different elements. The atomic mass of the carbon is 12, right? And the atomic mass of the oxygen is 16. So how many oxygen is present here? 2. There are 2 oxygen atoms. They forms an oxygen element, right? So it is multiplied with the 2, and if you add this, you will get the molecular mass of the carbon dioxide. It is very simple. We are considering the atomic masses of the element. If you add atomic masses, then it will become a molecular masses. But be careful. We should see that how many elements are present. Sometimes 2 or 3 may be present. We have to multiply with that atoms. Okay. We'll see how to calculate the molecular mass of the methane. So in your examination also, they are going to give a 1 mark questions or for the 2 mark to calculate the atomic mass and also with the molecular mass. Atomic mass till now they have not asked. Molecular mass definitely they are going to ask. You must know that how to calculate the molecular mass. So here I am considering the example of the methane. So this is the structure of the methane, which consists of single carbon atom attached with the 4 different hydrogen atom. So this is the atomic mass of the carbon into plus 1 into 4. Why it is 1 into 4? Because there are 4 hydrogen atom will be there, right? So 4 into the atomic mass of the hydrogen. So it will become 16.043. 16.043, and this is the way you need to calculate the molecular masses simply by adding the atomic masses of the each element. Then coming into the molecular mass of the water. So we know that in a water there are 2 hydrogen and 1 oxygen will be there. How to calculate the molecular mass? 2 into atomic mass of the hydrogen plus 1 into atomic mass of the oxygen. So 2 hydrogen will be there. So 2 into the atomic mass of the hydrogen and only 1 oxygen atom will be there. So this is the atomic mass of the oxygen. If you add this and multiply it with the 2, you will get 18.02. 18.02. So this is how easily we can calculate the molecular mass simply by adding the atomic masses of the each element and multiplied with the number of atom if it is there. Okay. Let's see with the other example also. So here I have listed out the 2 problems. One is calculate the molecular mass of the glucose. Molecular mass of the glucose. So how many carbon atom will be there? 6. How many hydrogen will be there? 12. How many oxygen will be there? 6. C6H12O6. Then molecular mass can be obtained by adding the atomic masses of the each element. We know that for the carbon, what is the atomic mass of the carbon? Is 12, right? How many atoms will be there? Here 6. So into 6, okay? Plus atomic mass of the hydrogen is 1 into how many hydrogen will be there? 12. Plus what is the atomic mass of the oxygen? 16 into 6. Why it is 16 into 6? Because the 16 is the atomic mass of the oxygen and there are 6 oxygen atom will be there. So 16 into 6. If you simplify this, you will get 180. You will get 180. And also you should express in mu, okay, or a gram per mole. Gram per mole. This is how we can calculate the molecular mass of the given molecule. Okay. And another example also I have taken out just to make you to understand, that is naphthalene, and the formula is C10H8. How to calculate the molecular mass? Molecular mass, which is equal to sum of the atomic masses of the element. Here the atomic mass of the carbon is 12. Okay. How many carbon atom will be there? 10. So into 10 plus atomic mass of the hydrogen is 1 into 8, because there are 8 hydrogen will be there. If you simplify this, you will get 128 gram per mole. Gram per mole. This is how we can easily calculate the molecular mass of the given element. So you must know that how to calculate the molecular mass, because for your examination also, for the 2 mark and also for the 1 mark, they are going to give the molecules like this, and you have to calculate the molecular masses. Okay. Next is gram molecular mass. Just now we have observed that atomic mass can also expressed in a gram. Like that, the molecular mass also can be expressed in terms of gram. Then it is said to be gram molecular mass. The example is molecular mass of the oxygen is 32 AMU. 32 AMU. If you written in the gram, then it will become a gram molecular mass. It's very simple. Then coming into the formula masses. What is this formula mass? It's a new terminology. Now we know that what is the atomic mass and what is the molecular mass. What is this formula mass? We all know that in few compounds, especially in the ionic compounds, the formula of the compound does not represent the molecule. Does not represent the molecule. If you consider the sodium chloride, okay. So here the formula does not represent the molecule, right? So the NaCl is a formula for the sodium chloride. It does not represent the molecule, because here the constant particles are the ions, right? In such cases, how to find about the molecular mass? It's very difficult, no? That is why we define with the new word known as formula masses. We cannot say it is a molecular mass. We have to call by the name called formula masses. It has been suited only for the ionic compound. Remember what we have discussed in the other example like ethane, methane, etc. and with the naphthalene, water and also with the carbon dioxide. The constant particles are the elements and also they are molecule, right? But here, if you consider the ionic compound, the constant particles are the ion. Here, we cannot say it is a molecule because it is made up of cations as well as the anion. In such cases, how to calculate the molecular mass? We cannot use that word as a molecular mass because the constant particles are ion here. That is why we are using the another new word known as formula mass. Formula mass that used to find about the formula mass of the given ionic compound. How to find out this? By adding the masses of the each ion. By adding the mass of the each ion, we can easily calculate the formula mass of the ionic compound. Here, for the sodium, the mass is 23 and for the mass of chlorine is 35.5. If you add these two, you will get the formula mass of the sodium chloride. This is how, if the compound given is ion, we use a formula mass to find about this formula mass of the given compound. Remember, we should not say it is a molecular formula, because the constant particles are the ion. That is why we are using the formula mass as a new terminology to find about the formula mass of the given compound. Simply by adding the masses, you will get the formula mass of the given compound. This is all about the today's session. In the next session, we are going to discuss with the mole concept and also with the percentage composition. So, till that, I like to say that what we have discussed today, it is very important topics in your first PUC chemistry, because other topics which we already learned in your previous classes, that is in your 10th standard. But from the atomic theory, you are going to understand the advanced subject in your chemistry, and it is very simple only when you understand a concept. If you want, you can write down the few things as well as the definition and try to practice it. Please practice the chemistry and try to note down the definition, and take care of you and be safe at home. Thank you.